Hello, good afternoon.
Yeah, good afternoon, sir. We shall start the session within 1 or 2 minutes. Okay.
Oh, yes, yes, thank you.
Okay, sir. So, good afternoon, everyone present in today's session. On behalf of Smart India Hackathon team, I welcome Shri Ranjan Das Gupta ji, who is Principal Scientist and Head TCS Robotics Research Data Consultancy Services, and all the candidates to today's online training session. I am Ashish Sharma, your host for today's session. This session has been specially organized to help you understand the today's topic, that is robotics and embedded systems, which will support you in preparing better for SIH 2025. We are honored to have with us our expert trainer Sri Ranjan Das Gupta ji, an industry professional with extensive experience in this domain. Thank you, sir, for joining and providing training to our candidates. Now, without further delay, I would like to invite our respected trainer, Sri Ranjan Das Gupta ji, to begin the session. Ranjan sir, over to you now.
Yeah, thank you uh, for this warm introduction. And let me know that am I audible to all the audience? Is it clear?
Yes, sir, you are audible.
Okay. So let me share to my slide. Is it visible, right? Oh, so
Yes, sir.
okay. So thank you very much and for this invitation. Uh, See, this is a 90-minute session where I'm going to talk on embedded systems and robotics. I know it's very hard to finish within time because both of the domain is very much exhaustive. But I will touch the main topics and probably at the end, if we can interact through some questions and doubts, then probably it will be fruitful. So I will start my tutorial session on embedded systems. I expect that uh, the audience has a little bit fair knowledge about what an embedded system is and what are the different boards are available, and they have a basic knowledge on microcontrollers as well. So today I'm going to talk about two different and very important microcontrollers. One is called MSP 430, which is from TI, and another is ESP32, which is from Expressive from China. And then I will talk about RTOS, which is real-time operating system, followed by this is slightly typo here. It is MUCOS. So MUCOS is one of the famous RTOS variant, which you can run and deploy on a MC unit. It may be a 16-bit or it may be 32-bit, but it is well adopted. And then I will give you some features of Eclipse ThreadX. So if somebody are involved in embedded systems, you probably know that initially ThreadX was actually a proprietary software, but since 1.5 years, it has been available as an open source, and it is actually available along with the Eclipse Foundation. So you can download the Eclipse and then actually you will get the ThreadX operating system. That's a fantastic operating system for specifically for ARMS devices, whether it may be ARM 7, ARM 9, ARM 11. It's a fantastic thing. And the last but not the least is this RT Linux. Okay, so which is a real-time Linux. Though I'm not going to touch about embedded Linux, but I will actually show you what is RT Linux is and how actually you can install RT Linux on a device. Okay. Now regarding MSP430, I will just touch upon all these things. I will give you the brief overview of 430, then its peripherals and the different derivatives. It is basically manifest from 8051 only. But there are a hell lot of difference between the typical 8051 architecture to MSP430. And nowadays it is 430 5x series, right? It's very, very useful. So uh, even if you are very much interested, you can actually join TI developer forum, so e2ti.com. So there are actually a lot of things actually you can ask if you have any doubt, and if you go to the TI site, you will get plenty of information with respect to tutorials, how to program the code, and all these things. Then definitely tools and software and some sort of wireless embedded devices, which is also developed and actually distributed by TIs and their OEMs. Okay, so now if you look into the TI MCU portfolio, it start with C2000, then moving to TMS 470, and then MSP 430. So if in SIH, in projects, if you think that there are some projects you have to extensively work with motor controller, right? It may be a PWM controller, it may be a quadrature PWM controller, right? So C2000 series, which normally you used to call digital signal controllers. It's not a digital signal processors, but it's a digital signal controllers, which you can look into it. Okay, but definitely it should be the applications where actually you have to create the motor drivers, right? Maybe single phase or three phase motor drivers and their firing circuits as well. Okay, so this is mainly meant for, and 150 mbps is the standard execution speed. uh, Even if you go to some microchip products, there also you will get the digital signal controllers, though microchip is very familiar with peak controllers, which are 16-bit 32-bit MCU itself, but there are digital signal controllers also available. Now moving forward, you will get TMS 470, which is a fundamentally digital signal processors. There are from 470 we have actually got to different 54x 55x series. Okay, 64, 67. Then you got Da Vinci series, 64x Da Vinci, OMAP series, right? So these are all basically ARM processors, and these OMAP, Da Vinci, they are basically a combination of ARM processors and DSPs. Okay, so in one side you have 32-bit ARM processor, which is a RISC core, and on the other side there is a DSP processor, and actually they can communicate with each other through DSP BIOS. So if you think that your project require both real-time response as well as high compute, right? For example, if you have to implement FIR filter or IRR filter, right? Or maybe you have to do some sort of what can I say, convolution, right, in the frequency domain, then DSPs and all these things will be extremely useful, right? And then coming to MSP430, which is our present context, is it is a extremely low power microcontroller. It's a 16-bit, 32-bit, both variants are there, and it have plenty of GPIO pins, supported peripherals like ADCs, DAC, comparators, right? It has a POR circuit. POR means power on reset. BOR means brownout reset circuitry. So all these things are there, and even people are actually trying to port real-time operating system on MSP430 as well. But if you explore free RTOS, just you can note on this point. This free RTOS is also available on MSP430, so you can try to put a real-time operating system on MSP430 instead of just creating a super loop architecture and create the functions in the IAR workbench or code composer essentials. Right? Instead of that, you can put a real-time operating systems. That will be a good exposure for you to do these projects. And these are all main applications we already know: medical and industrial metering, sensoring, utility metering, portable consumings, right? These are all various applications where MSP430 is being used. And it's actually, I'm working on MSP430 from 2000, around 2006-7 onwards. So even MSP430 is extremely popular, but ESP32 is also, because ESP32 has been launched on 2016 onwards, right? It's a derivative of, I think, ESP2866. So it's an upward version of that. Okay. Now, if you see that it has a very low power down, zero point 0.1 microampere, so hardly nanoamperes range. It has 800 nanoamps. So, current consumption also very less per million instructions per second. So you can look about these 16-bit RISC CPUs, but 32-bit is also available. Though I didn't mention it, probably 54 series, they are actually come up with 32-bit versions. So they have, flash systems, 128 KB to 56 KB flash systems, in-system programming facilities, and then intelligent peripherals, emulations, right? Embedded emulations of these things. So sometimes they have USB debugging interface. Sometimes they have direct JTAG debugging interface, right? Where actually you can do the in-circuit emulation. So this is the fundamental thing that mostly, it is actually in the standby mode always in your applications. Hardly it will go to the active mode. And so it's actually extremely low power, minimum active duty cycle. You can see that on time is substantially low with respect to the off time, right? So interrupt driven performance and demand. So I think there are, 7 or 8 different type of interrupts are available, right? For example, ADC interrupt, TAC interrupt, right? Then comparator interrupt. So all these things are there. Supervisory control. If the voltage is actually goes down below 1.7 or 1.8 volt, then actually it goes to the reset cycle. So these are all available in the data sheets. Go through the data sheets and all. I'll give you this overview. Different type of clock frequency. You should know how actually you can efficiently use the clock frequency as well. One is for low frequency range around 10 to 12 kilohertz, which is called a clock, or always low frequency clock, something like that. And DCO is digitally controlled oscillators, which is actually working for 50x of kilohertz, or maybe a few hundreds of kilohertz, and it may reach up to 16 megahertz or 20 megahertz, right? But it's a very stable as compared to a clock. Okay. Now, as we know, this is you can see what is the power consumptions. It's a very stable power consumption with respect to the clock frequency. No need to say about it. It can be driven with 2032, right? It's a coin cell, right? So with a coin cell, actually, we actually in TCS we developed one remote using MS430 controller for set-top box. Okay, by doing these CR2032 battery systems. So you can see this SVS is nothing but your supervisor of your power systems. Okay, so you can configure it for an external interrupt as well as internal interrupt also. Okay, so and then there are multiple operating modes, as I said. So it is not only a power down mode or deep sleep mode or different type of sleep mode also, but normally it work on standby mode, where actually it takes a very minimum power consumptions, and then there is an interrupt so that you can actually wake up the processors very quickly. Okay, so operating range is between 1.8 volt to 3.6 volt. As I said, if the supply voltage comes down to 1.7 or 1.8 volt plus minus zero point 0.2 volt, zero point 0.2 volt, something like this, then actually it will be go to brown on reset cycle. Okay, this is what the figure is. How actually the different current is actually changing over time, right? Different consumption cycles. So that you are going to integrate a real-time clock, or you want to integrate some different type of sensors, right? How the current cycle evolves over time. This picture actually shows you. Okay, so from 2 microampere it can jump to 620 microamperes. So such type of variability it has. Now, as far as RISC CPU is concerned, it said orthogonal. So, what is the mean of orthogonality, right? So, instruction, actually, if there are 7, 8 different type of instruction modes available for MSP430, but the beauty is that any type of any type of instructions is actually supported by different type of addressing modes. Maybe 5 or 6 addressing modes is supported by MSP430, but any different type of instructions should be supported by all different type of addressing modes. That's what orthogonality talks about. Okay, so byte processing, word processing, all are supported in a single cycle. Similarly, the beauty is that it is actually we have C supported compilers from which is available directly from Code Composer Essentials, as well as if you try to install IAR Workbench, there also you will get this C compiler friendly, where actually you can write your interrupt service routines, reentrant code, non-reentrant code, all these things actually you can write. Okay, even you can embed assembly instructions as well, if you are very much interested to play with. Okay. So this is, as you know, this is very small in size and power. I'll just quickly skim it. JTAG, it's a very important thing, right? So in MSP 430, actually there is a special, you won't get for all the variants of MSP 430. But actually, most of the time, you have a JTAG interface in 2x series, 3x series, or 4x series, even 5x series also. But there are some devices which is available in the form of a pen drive, right? It's just like USB pen drive. USB authority is available, so there actually you won't get JTAG interface. Basically, it is a USB debugging mode you have to apply. Okay, so in that JTAG interface, you have TMS, right? Then TCK, which is main for the clock instructions, then data input, data output, and this is a master clock, right? So all these things are available so that actually you can actually create the watch variables, then you can do step debugging, you can set breakpoints, right, after executing multiple instructions, and then you can look for the watch variables. All these things are actually very much possible in MSF 430, or even actually you can instead of ICE in circuit emulator, actually you can use some sort of trace debugger. Okay, where actually you can mm, go on observing the stack variable as well, how the stack is going to be changed, right? So it's give you a lot of flexibility to debug the systems. Okay, this is what the idea I'm talking about, and this is the in circuit emulator, which is normally coming from the the OEMs. It's not directly coming from the Texas Instruments, but Texas Instruments has their original equipment manufacturer, eco cycle through which actually you can bring the boards. Or nowadays they are also available in eBay, Adafruit, right? So it is also available. But I always recommend that you should go by a proper channel so that also you can get support from them. Okay. So this is the typical IR workbench through which actually you can write the code, and then you can deploy through these you know IC or debugger, right, in circuit debugger, and this is what the board is. Okay, on the right hand side you see this is the MSP430 board. So this is a little bit older figure. So these interface you see this is a parallel serial port interface. Nowadays it becomes replaced with a USB interface. Okay, and this is what actually you can see the code stack, correct? So all the memory addresses and the hex codes with the ASCII and extended ASCII versions, you will see this is a very standard interface. Most of the times you will get it, right? But though it is not available for the Arduino interface, but if you are well familiar with different type of MCU IDEs like Kill, right? Kill is one of the very popular IDE interface. So we'll get all these stuffs. So intentionally, I should not talk about Arduino boards. I will not going to talk about Raspberry Pi boards, right? It is most of the people nowadays are become very much familiar with all these stuffs. So that's why I pick up this processor. But it is much, much better than Arduino. Much, much better than your, Pi. So Raspberry Pi board. I mean, if you consider the ARM processor inside in it, it is MSP430, which is an MCU. But if you go to the TMS 470 series, and if you take the OMAP variants of that, right, or Da Vinci variants of that, they are much much powerful than Raspberry Pis. Okay. So this is same thing, SPI by wire system. That's why I am talking. So in case of JTAG, you see there are 4 wire signals, right? TMS, TCP, TDI, TDO. So except that VCC and ground. There are fundamentally 4 signals are available for in-circuit debugging, right? But in case of SPI by wire system, as I said, no, there are some variances available in pen drive, right? It is just similar to USB pen drive. I think you will see some pictures over here. It is actually 2-wire debugging interface. Okay, so it's a little bit very difficult. So I will say that don't go by that particular version until and unless your application should be in a very very teeny applications, right, where you need a very small chips to do the job, right? If it is not the, let's say, normally in the smartwatch you will see such type of MSP430 or maybe such type of MCUs is going to be used. But if your applications is around smart metering, right, or maybe some medical devices you are going to develop, correct, or in the traffic signaling, control the traffic where you have to run and web server and all these things, don't go that particular versions. Okay. So this is the different variants of, I mean, it's a fairly comparisons with different type of microprocessors with respect to the code size. Okay, so how actually it will vary. So you can see that 8051 has the the largest code size. Okay, Atmega is also very good to some extent. It is comparable, but MSC 430 is beyond comparable as far as the code size is concerned. Okay, and don't compare ARM 9, ARM 11 with microcontrollers because they are extremely powerful and architecturally they are different. Okay, so up to ARM 7 can be compared with 8051 derivatives because they are all derivatives of 8051. Okay. This is what I talked about. So this is the latest flash emulation tools. So nothing new here. It's very readily available in the market. Now moving to peripherals, these are all the list of peripherals you can see. Though you see some of the peripherals is not supported by all the devices, or I mean all the derivatives, but you will see there is a permutation combinations available. Let's say in the latest MSP 430 probably you won't get USRT or USCI. Okay, instead of that only USI, which is universal serial interface, normally is available, right? So such type of mix and match will be there. So when you go through the data sheet, it will be very clear. So you buy a device, you buy a development board, and then thoroughly study the data sheets, and then actually go through the application notes. That actually helps you a lot to understand the processor first, and then start developing your applications. And then you figure it out your project plan, and then try to build the applications also. Don't just like of Arduino board, just plug and play. It's not, don't do that exercise that it will be a plug and play operation. No, it's not like all the sample codes are available in the sketch form. No, it's not like that. TI will give you the application notes, and which actually give you what are the different features actually you can exploit over MS430. But that code direct, don't understand that you can directly apply those code in your applications, right? So improve your conceptual things and then try to apply it. Okay, so it's very important to understand the peripherals. Otherwise, you cannot, use it with its fullest capability. So that is the thing. So you can see in the left hand side, 10-bit ADCs are there, 200 kilo samples per second, right? It's not a cup of joke. So how fast it can samples. Then how many different type of modes are there? You see single sequence, repeat signal, repeat sequence. How does it differ? Single sequence means, let's say I have an ADC and there are 8 channels, right? Now, if I put it in a single sequence mode, what will happen? All the channels will be scanned in a periodic manner. But if I go by a repeat single, then what will happen? One particular channel is only being scanned, definitely within a periodic order. But out of 8 channels, only one channel will be scanned. And repeat sequence is, you can actually figure it out that how many channels you want to scan periodically. Not all the channels, not a single channel, but let's say there is a group of channels you want to do it, right? So in that case, so these are all the different tricks that you have to play with your applications so that your end user device or end products will be very much efficient. Okay, now data transfer controller, right? This is what actually saying auto scan and then DTC, right? How both you can enable. So DTC is direct transfer. That means it is not, it is similar to a DMA, right? It is not going to involve the CPU at all or the core of the CPU at all. It actually directly scan the data, it put into the memories of the ADCs and then transfer it to the internal memory of the CPUs, internal memory of the MST430. It is not going to involve CPU core at any point of time. So that is the beauty. So that you have to know how in application note you will see how to actually program the registers and how to enable that DTC transfer. Okay. Similarly, the same thing actually we are talking about DMA enabled this an ADC part. And SD16, this is a sigma delta. So normally the standard ADCs, they are not sigma delta type. They are maybe R1 network or I cannot remember what the specific type of analog to digital conversions it is happening internally. But sigma delta conversion is different from the standard ADCs. So whenever you need a sigma delta conversions, you have to select the that corresponding system bit sigma delta ADCs itself, which is supported by the 430. Don't go by the general ADCs. Okay. Then there is a 12-bit DAC also, 8-bit to 12 monotonic DAC is also available, digital to analog converter. And here also actually you can program the DMA versions, how actually you can load the data, digital data, and actually you can transfer it from the internal memory to the DAC directly without interrupting the CPU. So that also is required. So that's what is increased system flexibility, no code execution required, lower power, higher efficiency, all these things. You can see the graph, right? How the efficiency is going to be increased. Okay, even the beauty is that even actually through the GPIO interface, you can actually put the external DAC also. No need to consume the internal DAC always. Maybe if the internal DAC is not sufficient enough, probably you can use external DAC also, which is also available from TI. Correct. But do one thing that whether let's say I want to use a DC-DC converter in my embedded design, right? So always try to remember that if you work with TI products, try to inherit all the products which is available from TI, whether it is a DC to DC converter, whether it is a power supply supervisory controller, right? Whether it is a FTDI to serial converter, correct? Or whether it is a standard USB to serial converter. So all these things try to incorporate from the TI itself. Now, that's the best practices normally we used to follow. Don't go by mix and match until and unless it is, there is no any other way to solve the problem. Then probably you can pick up the other peripherals from the different semiconductor vendors. But usually it will be create a homogeneous system and they will work uh, very efficiently. Okay. Then coming to the comparator also, different type of comparator interrupters there with respect to the time, but through the timing timer interrupt, actually you can multiplex different type of comparators. All right. So then come to the serial port also. You can see there is a USCIA, USCIB. So there are two different type of. I mean, identically they are same, but actually they claim that USCIA is mainly for SPI type. How many type of different type of serial communications are there? One is typically I2C we used to use, then SPI, right? Serial peripheral interface, correct? Then I square S, which is mainly for audio signals, right? So this type of serial okay, another thing is RMT, which is remote mode transfers, normally used for IRD devices, infrared devices, right? Maybe you can do RC5 coding, or there are different RCMM coding, right? All these things, if you need, you can do with this type of serial interface. So you have to play with the different serial ports and then figure it out which is the best one for your applications. Okay. Both master slave is actually supported by MSP 430. That means when it is a slave, then there is a daisy chain is going to happen between the master and the slave. But when it is a master, it is going to actually support all different type of slave devices in a single I2C communication. So this is a standard USCI, this which is slightly different from USCI. Previously, it was USCI, so it is Universal Serial Communication Interface. This is called Universal Serial Interface only. Okay, that means here actually only one peripheral which simultaneously, definitely not, which is it should be mutually exclusive. It cannot support both SPI and I2C at the same time, but it is a single peripheral which is actually going to support you both I2C and SPI. Okay. Okay. It basically, each and every time when there is a research is going on, the main motto is to how to reduce the load of the peripherals. Okay. Because in the extremely deep power mode or deep power down mode or deep sleep mode, most of the power is going to be switched off except the core CPU power. So most of the power is going to be switched off. That's why it takes so much less current, okay, in the order of nanoamperes only. So these are all the just the summary of the MSP 430 portfolios. Now going to the different derivatives, I mean the different variants, right? What you come across is the general overview with respect to the MSP 430 core and then its associated peripherals. Now we talk about something on MSP 430 derivatives. So this slide you should keep in your mind that, right? So integration versus performance. So it is well known, right? As an engineer, you should always know that, right? The more complexity means you will get more performance better, we know. But power consumption will literally, will become a question. So we can see that how the catalog has actually moved from 1x to 2x, then from 4x to 5x. Okay, in 5x you will get 256 KB flash. So in your application systems, you have to figure it out that what will be your code size. Do you need such amount of flash is required? That's a question. Okay, but, by default, I will try to run Ubuntu in my system. Let's say, go to the Raspberry Pi. Everybody runs their Ubuntu kernel, right? Uh, inside your chip. But is it really required to run an Ubuntu and to get all the functionalities of Ubuntu? I am not comparing with the desktop Ubuntu version, but still, is it required? Do I need a file systems? So all these things is a question when actually you are going to design your applications. So what will be your footprint? You have to calculate, or you have some design thinking process to which actually you will be able to say, okay, 256 KB is an overkill for my applications. I can easily manage with 128 KB. Then why should I go for that 5xx versions? Okay, I can come down to 4x version. What type of display? Do I need a simple, LCD display is enough, or do I need an OLED type of displays? Okay. So this actually gives you how to select, because there are a lot of peripherals, I mean, a lot of derivatives are available, but you have to select which derivative will be the best for your application or most suitable for your applications. Okay. So different type of features I'm also talking about. So most of the times are general features. Less than 1 microampere standby current, which is an improvement, right? This is called LPM3, low power mode 3. So there are three different low power modes: LPM 0, 1, 2, and 3. Sorry, four different type of low power modes are available. Okay, enhanced watchdog timer. So it's the improved performance of the watchdog timer has been improved. I don't know what performance it has been improved, but they're claiming that. Okay, so these are all the general purpose devices. You can see that starting from F201, F202, 3, then F121, right? Just changing in the flash size and the RAM size, then changing in the timers, right? Then different type of changing of communication, comparators, right? So you can have a good comparison with this. Okay. Then flexible clock systems. So actually, a clock is not directly programmable here. So you have a very low frequency oscillator through which actually you can generate the clock. That's the difference. DCOs will be remain same, but a clock is actually modulated by the VLO. That's a different thing. So there is an embedded 12 kilohertz oscillator which actually gives you the which can generate the A clock, but you can scale it as per your requirement. So you can use directly 12 kilohertz, or you can scale it. Let's say X by 2 or X by 4, right? In that way, actually, you can scale it. So you can add crystal oscillators is always there inside in the chip. So these are all the just changes they have made, right? So 430 architecture, 120 kb flash, that's what I talked about. Then these are all the different type of applications: target applications, smoke detectors, battery chargers. So if you have any applications with respect to battery charger, you can think of this either 20x series or 21x series, right? All these things are merely. So if you want to around with 8 kb, 10 kb, right? 10 kb flash, right? This type of processors is well enough, right? Don't go to the 3x versions, or don't go to that 4x versions, where actually there is a big jump happened in the flash memory, and definitely it incurs more cost. Okay, and also you try to figure it out. How many peripheral support you need. Then coming to 4x series, these also standard LPM3 mode, zero power BOR, same thing is happening. These are also, you can see the various different type of derivatives are available with very much comparisons. How many pins are there, right? So most of the time we're not designing our own circuit board, right? We used to take the DVVM board or development board and attach different peripherals and actually try to close the project, right? But ideally, if time permits, you should have your own PCBs. That's the best way you can do it. Okay. Now for 30 FX series, 16 mega CPUs. That's a very good. 32 into 32 multiplexer units, multiply units, right? That's a big jump. Initially, it was 32 into K. That means you can directly multiply 32-bit number with an 8-bit number. So that's a big thing, because no software multiplication is required. It will be extremely fast. But in 47x series, 40x, 412x series, 47x series, they've actually improved that. So directly 32-bit into 32-bit multiplication is possible. Hardware multiplication is possible. Okay, that's a significant change. Then instead of 8-bit, 12-bit sigma delta conversion, you will get a 16-bit sigma delta conversion. Here is also a question. So how to select that A to D converter? What's the resolution of the A to D converter? Whether it should be a 12-bit, whether it is a 16-bit, or 8-bit is more than enough. That as a designer you have to think of and choose the actual derivatives, right? Otherwise your derivative become a lot of features are there, but hardly 20% or 25% features of the capability actually being used in your application. Rest of the things are actually idle. So then it's not a good design at all. Okay. Then coming to the next generation is A5X series. advanced ultra low power, increased performance. So they are go on increasing this. Lowest active current is 120 micro LDO, POR, WDT, all these things we know actually. So WDT is watchdog timer, real time clock, then brownout reset, significantly longer battery life. They are actually claiming. So 1.8 volt flash erase and write time. That's also a very critical time. So ideally, in other derivatives, actually, if you want to program the flash and if you want to erase the flash frequently, hardly we erase the flash, but sometimes is required. Correct. So it takes around 2.2 volt or 2.3 volt to do this operation. But here actually it comes down to 1.8 volt. So that's a significant change. Okay, flash writing and flash erasing operations. Then go to 5x series. It's up to 25 megahertz it can go. I'm talking about 16 megahertz, but now again it has been improved to 25 megahertz. Okay. So obviously it will available in the cost of more power supplies. Okay. So obviously it should not operate in a lower power supply mode. 3.3 volt um, is not sometimes enough to generate or to support a 25 megahertz and above clock frequencies. Okay. So increased functionality, modern design options, encryption also. So I never worked with that. So I cannot comment on this, what type of encryption it is actually being supported. Then integrated voltage reference, user defined bootstrap loader, all these things are there. Power management module, then same instruction set can be used. The beauty of this MSC 430 is that instruction sets, no, they are more or less identical. Hardly 10%, 15% change has been made across the derivative. Though you see that there are plenty of differences is actually coming in the hardware level. But at the instruction set level or in the addressing mode level, they preserve whatever that is. They preserve the back compatibility always, and the orthogonality also. Okay, so any instructions can be used in any type of addressing modes. That's the key here. Hmm. Then come to tools and softwares. Code Composer Essentials, as I'm, always I'm talking about. It's a very good tool. Its free version is available in the TIO site. You can download and you can use it. You have to select the board, and then you can start the programming. Because moment you select the board, automatically all the relevant header files will be included, and you can start working on that. So just do some hands-on, then probably we'll get some exposures. Okay. Then other type of websites is also there, IR Workbench, but IR is not free. So it's a licensed version, so you have to pay the license. So though some free ones are available, but they're very limited actually. See, limitation comes with respect to the compiler. Limitation comes with respect to the code support. Okay. So compiler limitations means all different type of macros, right? Compiler directives is not going to be supported. That's the one thing. And the second thing is that maybe you cannot generate a code base which is more than 8 KB or more than 10 KB. So code generation is a big problem for the licensed softwares. Even if you give free one, you'll see that you cannot generate the code efficiently. And the compiler is also not efficient because there are different type of compiler options available to optimize it. Let's say I want to do O0 optimization. I want to have O1, O2, O3, right? Speed optimization is required. So you won't get such type of different type of compiler optimization support in a free version. Okay. Crossworks is a fantastic tool. It's available in Ravale. I personally worked on Crossworks. I personally worked on IAR and as well as Code Composer. Earlier, it was not actually Code Composer Studio Essentials. It was Code Composer Studios, meant for only DSP and digital signal controllers. But now they have enhanced to CCE itself. But they are not same. Okay. GCC toolchain I hardly used, so I cannot comment on that. But as an engineer, you should also try with that. It's a completely free version, but you should have a very good Linux exposure to this, particularly in case of GDB, because you way to debug it, right? If you use this GNU/CC compiler, because you won't get the IDs nowadays. But maybe you can plug in the Eclipse IDE, and you can use the Eclipse debugger for that. What we used to do for the ARM processors, but to what extent it is efficient with respect to MSC 430, I cannot comment on that. Okay, but definitely you can try. before jumping into the project, definitely you can try with this. Okay. Now, different type of emulators I can show you, right? So this is what the pen drive like MSC 430. It is a fly-by-wire systems. So 2Y system. So it's very cheap actually. But the fantastic thing is that it also contains RF modules, which is called as RF 2500. Okay. So that's the beauty of this. This is a module which actually has RF module also. Okay. Now another variant is EZ430, which is also well known. Flash emulation tools I also talked about. So you can search in the net, you will get these things. This is one of the I won't say this is the latest board, but this is one of the very popularly used boards. So you can see what are the things are available here, right? So you can have an RF expansion slot, you can have an audio input, you have a serial input RS-232, right? Mic and all these things are there. So this is an LCD display, but definitely it is not an OLED display. So all these things are available, which is carrying $100 cost only. Okay. Now this is another type of variance board for MSP 430. So there is called a Gill Instruments. I don't know whether still they are working or not, but you can search in the net. So Gill Instruments is a fantastic OEMs for TI products. Okay. This is for mass storage devices. You can see. So you can actually put the SD cards also, different type of micro SD cards or standard SD cards you can put. Okay. So this is for embedded web browser. This is also another variant for MSU 430. Then this is what actually I am talking about. This is a tear down version. So this is basically the debugger. Okay. If you see, this is actually the debugger. Means this is the main processor. So I mean this is the sorry, I wrongly positioning it. This is the thing where actually you can program the MSC 430 F222 series. Okay. So moment the programming is over, you can actually detach this, and then this system can be used as a standalone. Okay, so there is a cheap antenna always. There is these are all the solder pins through which actually you can connect your female connectors also, right? So that a lot of other things also you can add on with this card. So there is a reset button there. There is a CC2500, as I say. This is an RF module, right? It's a very good module, but only thing is that it's a little bit very difficult to debug actually, because it's a two-wire system. So it's very difficult to set multiple breakpoints. It's very difficult to see the trace of the different registers, right? It is a little bit tricky in this case. Okay, so this is another emulator. Then this is what actually we talked about. Now, if I go to the wireless systems, you can see that if there are some projects available with Zigbee or 802.15.4, this is one of the best choice. You can go by this. Please try to remember that F22X, F41X, or 241X, right? They mostly support these CC1X, CC2X. These CC1X, CC2X are also available from TI. It is actually they are RF transceivers, which is consisting of both phi and MAC layer, and you have a complete what I can say 802.15.4 stack, right? So you will get it, but uh, mostly see less than 1 gigahertz is very difficult to use. Let's say if you want to operate on a 878 or 904 5 megahertz, it will be a little bit difficult to use. Instead of that, you can go by 2.4 gigahertz, because already commercially available products, right? If you want to connect with an Wi-Fi router, right, or a Wi-Fi gateway, so it will be easy for you if we use 2.4 gigahertz ISM band instead of going to the sub gigahertz band. So in that case, don't opt these CC1XX series. You should opt by CC2X series. Please make a note on that. Okay, but Zigbee stack and IEEE 802.15.4 5MAX stack are already available. It is supplied by the TI. I don't want to talk about the network topologies, which we already know, and these are all the things. So TI Mac, right? So TI Mac is a proprietary Mac, but it follows IEEE 802.15.4 protocol, because hardly you will get time to develop your own Mac or own file, right? You have to reuse what is available in this, right? And it is actually available in terms of hardware abstraction libraries, right? So different service access points are already available, right? Whether it is with respect to the file layer, whether it is with respect to the Mac layer, SAPs are available in the form of hardware abstractions. Okay, so you can directly use that. So in the form of libraries, available in the form of libraries, and you can use it. Okay, so this is what actually I talk about 22C480. So accelerators. These are all for mainly meant for wireless sensor networks. Okay. Uh, so that's all for MSP 430. Now maybe you can move for ESP32, which is a very new product. Uh, so the first version of ESP 432 is, it is extremely different from Arduino Uno, right? So Arduino Uno is an 8-bit systems and it's a 32-bit systems, and it is more or less 10 times faster, 10 times faster than the Arduino Uno. Okay, and the second thing is it's a dual core 32-bit microcontroller. CPU cores can be individually controlled. The second thing, third thing is the clock frequency can go up to 240 megahertz. So just few minutes back we are talking about 16 megahertz, 25 megahertz, but it's now becomes 240 megahertz. But hardly we use these up to that clock frequency level. Okay, multiple power modes, as I said. So low power mode, standby mode, even there are divisions in the low power modes. Integrated Wi-Fi, Bluetooth, and BLE. So that's the key differentiator. So all TI processors or MSC 430 series, if you see, they won't directly come with Wi-Fi and Bluetooth or Bluetooth low energy. Okay, few models are there, but not all or not many of them. Okay, though Wi-Fi is available, Zigbee is available, 15.4 is available, but it's a very limited way. But here, and they have a separate transceiver also, which is RF series, right? RF 24x series or 2500 series, which is basically built on from CC1x, C2x. But here, yeah, most of the ESP32 chips is actually pre-built with Wi-Fi, Bluetooth, and Bluetooth low energy. So that's the key differentiator. So if you need a constant Bluetooth operation or Wi-Fi operation, let's say you are going to develop something where your system will work as a web server, and it has to it has to connect with laptops, it has to connect with PDAs or tablets or mobile phones, right? So it is sometimes it is work as a DSCP server. So then probably your MSC 430 is not enough. So you have to go to this 32-bit ESP series. ESP132, that is the mostly used series of MCU manufactured by Expressive, or higher said, successor of 8266. Recently introduced 2016. 1812-bit. See, up to 1812-bit analog to digital converter. So can't you imagine how many A to D converters they are going to support? Obviously, DA converters is a little bit less with respect to that ADC. Capacitive touch sensors, SPI bus, I2C bus, I2S bus, 3 watts. So very, very useful. SD card host controller, hardly you will get, because I have shown you a different board with a daughter board which supports your mass storage device. So mass storage device is not always available in the DV You need a daughter board for that in case of MSC 430. But here mostly you get SD card, right? Micro SD card you will get. There is another module called ESP32 cam. I will just go to that. So there is a camera module, and just the beneath in the camera module there is a micro SD camera is always available. Okay, for storing the images. IR remote controller, motor PWM, LED PWM, Hall effect sensors. So plenty of things are available. Okay. So most of the pins of 32 have multiple functions. Some functions conflict, not all can be used. That's a very key point. This is actually a very important point, that some function conflicts, not all can be used simultaneously. So whenever you choose the board, try to figure it out, that whether you can use all the functions through the pins. I mean, the functions are available or brought out through the pins, or internally they have used, and hardly 40% or 45% is actually come out as an external interface. So not all the development board expose all the pins. So whether you choose a Adafruit, whether you choose from SparkFun, whether you choose for Node.js ESP32, right, or whether you choose an Arduino ESP32 like stuff, right, Arduino, then probably you try to understand the complete description of the boards and then select. Then that will give you an informed decision, right? So otherwise you will see that, okay, I have bring out some board, but the functions are not available at the periphery. For example, if I go to the CAM board, ESP32 CAM, so most of the GPIOs and the Wi-Fi's are actually used by the camera. Okay, so hardly you will get hardly maybe 25%, 35% of the functions are available for your external projects work or for your external works. Okay, mostly it is consumed by their internal design. Okay. Some digital IO pins are input only. So this is what the basic illustration of ESP132. Okay. So you can see that it is 0, 3, 6, 7, 4, 18. So a lot of ADCs are there, GPIO pins. Okay. Uh, those GPS pins called the serial data and clock, like serial data address, then TX0, RX0, all these things are there. Okay, now ESP32 boards and modules. So as I showed you, so these are all the very different types. Arduino Nano ESP32 ST is one of the board. You can go through the description and then see it. Node MCU ESP32S, this is another one. SparkFun Think Plus ESP32 on 3.7 volt Leon battery. Actually, you can use, instead of giving the supply from the laptop or from the PC, actually you can use 3.7 volt lithium ion battery for this. So this is one of the advantage of using this SparkFun Things Plus ESP32 WOM. Then ESP32 S3 series, which is a little bit an advanced version of WR, the worm board. Then this is a very special type, SX1262 ESP32. Okay, so it actually supports OLED display. So organic LED is there. Then battery support is also there. Fantastically, it has have LoRa support. So if there is some application needs you LoRa support, see, Wi-Fi you get, Bluetooth you get, BLE you get, but there's an additional stuff you're getting, which is called LoRa. So if you need something like that, probably because LoRa actually do chirp modulation in the file layer. If you take Wi-Fi, if you take Zigbee, or if you take Bluetooth, basically it depends on the spread spectrum, whether it is a direct sequence, right? It may be direct sequence or it may be frequency hopping. It will be used. But in case of LoRa, it is a sharp signals spectrum, frequency. So that's why their file layer is going to be changed. So that's why they say that it additionally it supports LoRa as well. So that's a significant difference, and it also costs you more. And finally, CAM interface is also there. So camera interface, and there is an S3 module also available. I don't know about that S3 CAM, but it is there. It recently has come up. Okay. Now, ESP32 Wi-Fi, as I talked about, it supports Wi-Fi protocols 802.11.bgn. All are actually going to be supported. So that means it can reach up to 110, 150 Mbps, hopefully. Yeah, data rate is 150 Mbps, 2.4 gigahertz operating speed. Power transmitter is 20.5 dBm, plus minus something will be there. Then diversity of GPIO control RF switches, Wi-Fi library built in. It support both station and the soft access. That's the beauty you just try to remember. It is called STA mode. So station mode means actually, I will show you some pictures. Hopefully it is there. So I will come back to here later. Yeah, STA mode is ESP32 gets IP address from the router DSC. So that means if you see it here, this is what the STA mode is. Okay, so this is actually why work as a Wi-Fi client. So this is one router through which this router is actually working in a DSCP mode. So dynamic host controller protocol is running inside in it. So through which actually it will get the IP address. And similarly, you can create a network out of it through all these devices. So this is the thing of STM mode. That's why it's talking about that it gets the IP address from the router DSCP, right? Now, if you go to this mode, which is soft access point mode, it itself works as an access point. soft access mode. Okay, but the point is why it is soft access mode, why it is not traditionally access point only. The difference is that there is no connectivity or built-in connection through which actually you can get the internet. So backhaul IP connectivity is not there. Let's say I want to connect to IPv6 ultimately, right? Through which actually I will pass the data, and I want to access some data store or web server, right, or application server, or maybe at the cloud infrastructure at the backend. Then it is not possible through this API mode. Okay, then again you have to go through that IPv6 translation, right? Adaptation layer you have to incorporate. Then you have an IPv6 router, right? Gateway, and all these things will be required. So that's why it is called soft API. So it cannot give you the internet connectivity at the back. So that's the difference. Okay. So now if you go back to these, in the SAP mode, assigns IP addresses to the clients. So that means this mode is actually, it will going to assign all the IP addresses to all the devices, because it is acting as an access point. It's a master device. Okay. That's why it said maximum of 5 clients in the SAP mode. So maximum 5 number of clients can be supported in the SAP mode, and both modes allow ESP32 to act as a web server. That's one of the advantage. I will show you some videos how actually you can build the web servers around these ESP32, and through which actually you are going to control. Correct. So this is one of the example. I maybe I have some videos on that. It's a very simple examples talking about that how actually you can connect some LEDs, some tag switches, right, and some touch sensor. I mean touch keys, or you can connect to the ESP32, and then actually you can do some programming. There are some sketches are already available, so you can use it. Okay, I will go that demo one by one. So then there is an ESP32 Bluetooth version. So it has both classic Bluetooth and Bluetooth low energy version, can act as a client and as well as server. Classic Bluetooth for continuous data streaming, BLE for short bursts of data, Arduino libraries for Bluetooth and BLE installed by the default. So say for ESP32 actually, what I missed here is you can use your conventional Arduino IDs directly. You can use it, but there is a board manager through which actually you have to there is a GitHub link through which actually you have to install the board managers through the URL, and then through the board managers actually you can select the boards, right, whatever the boards I am talking about here. So these are all the list of boards. See, this is a very minimalistic list, right? If you go to the website, you will see there are plenty of boards are available. Even the board manager is also going to support you plenty of boards. So it is just a 5% of it. But the ideally what you have to do is that you have to install the board managers in your Arduino IDE first, and then you have to select the boards, number one. And then through that boards, actually, you are going to select some example codes or example sketches through which actually you can start testing your development mode, what you have procured for your project, so that you will get the confidence out of it. Then probably you think of how you can utilize the existing code base, whatever already available in the form of sketch, or maybe you have to write the code from the scratch based on your application need, right, or final requirement, whatever you say. Okay. Now, as I said, this is what the Bluetooth is. Classic Bluetooth is something like that, where actually is going to talk with different type of Bluetooth devices, right? Whether it may be a handset, whether it may be a speakers, right? So you can play an MP4 file inside your ESP32 board, and then you can play it back through the speakers, right, or your headphones. All these things is actually possible, right? You can create your own what I can say, iPod like stuff, right? Or something MP, portable MP4 player, something like stuffs. File transfers is also possible, correct. But in case of Bluetooth energy, this is, we always know that energy consumptions will be very, very less in case of low energy profile, because it is not working in a continuous mode, rather it works in a burst mode. So active versus standby duty cycle will be extremely low, right? So that's why it actually reduced. The average standby current consumption has been drastically reduced in case of BLE. That's why it is mostly used for such type of fitness bands or IoT sensor. IoT sensors is extremely useful because you cannot change the battery in case of, if you want to create a wireless sensor networks, which consisting of humidity sensor, temperature sensor, right, moisture sensor, or VOC sensor, right? volatile organic compounds, which actually it can detect. Maybe you have to detect magnetic field through the Hall sensors, right? In that case, you have to go by the Bluetooth Low Energy Profile configuration, right? Standard classical Bluetooth will not work here. Okay. Then these are all the different additional features: timer, Hall sensor configuration, repeat timer mode, right? Touch sensors, all these things actually you can configure it. Then before going to ESP, okay, let me finish this part, then probably I will show you the demos. So this is another variety which is called as ESP32 CAM, right? So which actually talks about camera interface, right? So it's a low-cost MCU, built-in camera, but you won't get right 4 megapixel camera over here. So the camera resolutions will be very less. Then if you want to integrate a high-end camera, then you have to design your own circuits. Okay. But it's okay, it's fairly good enough actually. So VGA resolution or little bit SVGA resolution you will get, right? All these things. Don't expect that you will get 720p or 1080p or 2048p, right? Don't expect that. But okay, fine, you can manage for any type of face recognition techniques, or maybe vehicle detection technique, right? So you want to detect the number plate of the vehicles. This camera is fair enough, okay, because you can apply OCRs. Whatever the image it is going to be captured by the camera, you can apply OCRs on top of it. So it's possible. So pinouts are subset of ESP32 module. So that means whatever the pinouts is supported by ESP32, it is not actually fully supported by ESP32 CAM. So it's nothing but a subsets of that, because most of the pinouts is actually consumed by the camera and is micro SD interface, because you have to store the camera images also, or maybe you have to store the video also. So that's why this you have to be remember whenever you use this camera module, you see that there will not be, you won't get the flexibility of having a lot of peripheral supports or a lot of pinout supports, through which actually you can use the GPIOs, you can use ADCs, you can use DACs, you can use comparators. No, it's not possible for this. It's restricted. Provision for external camera, though it has a built-in camera, but actually it actually supports external cameras as well. Okay. So I can show you that how actually you can connect an external cameras, and where actually you change the jumpers, okay, in the back side of the board. So this is the front side. On the back side, actually, if you flip it, then probably you will see there is a connector and there is a resistor. If you change the resistor, you will actually get the access of it. Okay, so this is for the illustration of ESP32 camera. The beauty is that it supports both 5 volt and 3.3 volt. That mostly ESP32 module. So you can play around it, right? So that's the beauty of it. Okay. Mm. Then CAM module has no USB port. That's the one thing. Initial programming done with external FTDI module. I hope that you understand what is FTDI is. So micro SD card is rated for 4 GB maximum. 4 GB storage capacity is given. Larger micro SD card can also do store. Even if you actually use larger micro SD card, say 32 GB or 64 GB, it cannot recognize beyond 4 GB. Okay, that's the thing. Component on both the sides of module not easy to breadboarding. That's the problem. So because see, if you go to this image, so you see that the components are actually populated on both the sides of the board. Correct. So if you just flip the camera, you see the micro SD here. But this is a normal standard CSI interface, camera serial interface, right? Which already available in Raspberry Pi board also. And on the flip side, you actually see the processor, right? You see the processor, you see the power connector, and there is an LED flash also. See, if you can look in my mouse cursor, you see this is an LED flash, which is meant for generate the flash signal, right? For the camera to work. Okay. So this is the mostly popular camera we are going to use. So OB2640. So there are 3-4 variants out there. So in the in the camera web server.h file, you will see that there are 3-4 variants of the camera is also well supported. But this is one of the standard camera we are actually using. okay, for this module. Fitted with 2.6 camera. You can see that this is what the camera I am talking about, and this is the flip side. Okay, this is the flip side here. Actually, this is the low dropout regulator, LDO. This is the reset pin. This is where actually you can connect the. This is a SMA connector, right? Through which actually you can connect some antenna also. Otherwise, you can use the built-in camera, which is already there inside in it. Okay. This is what the standard interface for FTDI. So you can see that. See the point. You please remember that whenever if you use this module for any one of your project, when you program this ESP32 cam, you have to short these two pins. Okay. But when the programming is over, you have to remove these pins and then reboot it, and the system will start working. Okay, just try to remember that. Okay, so this is what the STPI, FTDI to USB interface. Okay, this is normally available in the Spark Fund, so you can buy these boards from the Spark Fund and you can go on using it. So this is a simple connection. So VCC ground RxTX, right? Nothing, nothing more than that. So jump out GPIO 0 to ground for programming. Okay, so GPIO 0 is actually grounded by this wire, but you have to remove it. Please always remember this. You have to remove it when actually you start using it as an when you start using it. But when you start programming it, you have to short it. Okay. The cam module has an internal antenna, what I said, external camera IPX connector. So this is what the picture is. So this is the camera antenna connector, and here there is a 0 ohm resistance, which is internal. And if you just remove it and put it here, then actually it will work as an external antenna. Okay. So that is what actually. So if you use the resistor in this configuration, it will by default it will take the internal antenna, and if you just remove it and press it here, then I mean definitely you have to solder it, and then actually it will work as an external can. So external antenna can be inserted inside unit. Okay, so that's the change you have. Obviously there will be a change in the game. The moment you put the external antenna, there will be a change in the game. Okay, this is what the camera look likes. Okay. Now, before going to the auto sections, let me share you some videos. Uh, just give me some time. Mm. Yeah, hope you are going to see it. Uh, this is actually, if you see that https github content.com expresso.io Arduino, right? This is what, as I said, this is the place where actually you have to, bring out your IDE board manager. Okay, this is a very important point. It actually contains a JSON file, and you can see in the video. That's just you copy this link. Okay, and you just go to the preference and you will see that the beneath here, yes, here in my system it is actually already there, but even if it is there, you can remove it and put the URL over here, or maybe if there are multiple URLs is required, you can put a semicolon and go on appending it. And the moment you do and click OK, then what will happen? No, you just paste the URL and click OK, then actually the entire board manager will going to be installed with your Arduino IDE. Okay, this is the first step you have to do. Otherwise, you will not get the you're not able to select the boards and they're supporting. Yes, now the video is showing that how actually you can select the board managers, and then actually you look for, let's say, ESP32. Okay, so you just search it ESP32, and then probably you'll see that, yes, hey, this is installed. So that means the board manager had installed that specific boards along with all its libraries and header files. It is always available. If there is a missing in the libraries and header files, then actually you have to burn your hand, right? So there is no standard way to give you any tricks how to do it. Okay. Now it is actually going to select some this rover 1WRWM worm board. So it's very difficult for me to pronounce. It's a worm board actually, And this is the first example you can see where actually you can collect some LED pins as shown you in the picture. And then how actually it's a simple Arduino program, right? So you put a 500 millisecond delay through which actually you can do high-low operations, whether the LED will go on and LED will go off. Correct. All these things actually you can do it. And then if you move it to the here, so this is a GPIO pin. Through which actually the LED is actually going to be connected, and this is what the baud rate is, right? So 115.2 Ks. It's a pretty high speed baud rate. Okay, so then when everything, when there is a ready, then hopefully actually you have to is just let me see whether there is a download options it has been showing or not. Yeah, there is not there, but you can see this is what we are actually trying to do. So you just, there are two pins actually with this. So you can put one of the reset pin. So the moment it will push the reset pin, so what will happen, the code is already downloaded, and this is the configuration has been made. Now actually it go on working. Okay, so yeah. The next thing is that how actually we can use the hello message also. You can see how actually we can print the hello pin here. So you can see that initially it is only to use the GPIO pin, but now actually I use the serial monitor as well. So just wait and see uh, how it is actually happening, and you observe what is happening in the console also, right? So it's hard resetting by the RTS pin, and now it start working. Okay, so there are two LEDs actually. One is the built-in LEDs, and there is another is called the external LED, what I have put it. And then actually you can look for the serial monitor. So initially you will see there is a garbage in the serial monitor. Okay, and moment you reset it, right, so that goes off, and actually you will get the hello world informations. Okay, so this is why actually you can test your ESP32 module. So you bring the ESP32 module and you just go on do this simple testing so that you can find out that yes, more or less this is working. But one more thing what I forget to tell is that uh, this USB cable is sometimes giving problems. Okay, so because if you use a very long cable, USB, the drop will, the voltage will be slightly attenuated, and most of the time the programming is getting corrupted. I mean, when it is writing to the flash, it gets corrupted. Correct. That I have faced it. Okay, so I always use a very strong. I mean, there is a called USB power hub. Hope you know that. So there are 4 ports, 6 ports USB power hub is available, where actually you have to externally power the hubs. Okay, so that will be the best way to do that. Okay. To overcome such type of problems. Mm. Otherwise you feel, sometimes you feel difficulty, you feel that the code has been downloaded but still it is not working. So better use power hub. There is Belkin. If you go by the Belkin, they will supply the tetra hubs also, right? Power tetra hub, that's a very good thing. Now this is one of the example for the Wi-Fi. You can see how actually you go to the file, then select the examples, and then probably there will be the list of sketch files will be available. Okay, so I'm just selecting one of the sketch file, which is Wi-Fi, and then actually I'm looking for the scanning part, right? So let's say if I want to scan that how many Wi-Fi networks is around me, right? And what are their existing SSIDs, all these things. So these actually I can do it. So have a look on the code. So this is a simple. I put the serial baud rate first, so that actually I can detect, or I can get the data through the serial port. And then I actually use that definition, Wi-Fi STA mode, right? So that it can operate in that area. And now this is the bigger loop actually, where actually it starts the scan networks, right? Those, so Wi-Fi dot scan networks, it's a built-in libraries. So I need not to explain, because already you have known all these things in the Arduino, if you have Arduino exposures. And this is actually how you're indexing your SSID and receive signal strength indicator. Okay, so both way actually you can do this. So you can actually read the SSIDs, and you can read the corresponding receive signal strengths also. Now let's see, if I go to the serial mode, if I open the serial mode, as usual you will get a garbage, then reset it. The moment you reset it, it will start scanning. And you can see, so these are all the different networks it has found in the first iteration. In the first iteration, it has found 4 different type of networks along with their received signal strength. Now you can see that these minus 61 has, or minus 65 has a much more RSIC, right? It is having higher RSSI with respect to the other, minus 94, minus 88, right? They are far away. They are far away from the device. Okay. So this is the second scan. Third scan is actually doing. So it's go on doing. It go on actually giving you how many networks are there around it, and what is their SSID and RSSI levels. Okay. So this is one of the example actually we are working on that. Okay. Then if I go to little bit faster, let's say what exactly it is doing. Yeah, this is actually is for the AP mode. You can see this. So how this connect will. So you have to, first of all, you have to specify the IP address. Actually, here the default IP address is something like that, 192.168.4.1. That IP address you have to select. Okay, and then you have to select the port also, right? So port 80, right, through which actually you can send your HTTP request. Okay, and then actually you have to figure it out, that what is your you have to give your name, right? So which SSID name you want to configure, right? Or you want to because this is actually in AP mode, right? So it will actually work as a DSCP, and it is going to allocate the IP address for the other Wi-Fi clients as well. So it should have that SSID name. It may have password, it may not have password. Actually, you can bypass the password also if you need. But you should have a static IP at the beginning, based on which actually it is going to generate the IPs for the 5 clients you are going to connect in the soft AP mode. Okay. Now there is a simple test we have been done. That is an HTTP request, that how actually you can access through the browser, because it's worked as a web server, right? So you can, through the browser you can access it, and then probably you can use you can toggle the LED buttons through that. So it's a very simple. So your AP is through which actually your USB32 is actually going to be connected. Okay, now if you just browse it to 192.168.4.1/L, so you'll get the initial web page. You can create your own beautiful web page. Now, if you go low and high option, the LED will be glow on, and if you put the low option, it will go off. Like this, it will work. So it's actually gives you some sort of web server applications. So you create a web server through which actually you send to whom actually it is sending you the HTTP request, and through that HTTP request, we are going to control the LED ports. That means remotely control applications has been demonstrated. It's a very simple application, but it gives you idea that how you can remotely connect and access or control the devices. Okay, so there is a similar thing actually, where actually both Wi-Fi APM mode is there. So similarly, you can see that it is actually connecting as a SAP. Okay, so that in the SAP mode, basically you have to give your SSID. So you cannot configure the SSID, or you cannot set your SSID. Here you have to give some known SSID through which it is going to connect. and definitely you have to give the password also, right? Otherwise it is in client mode, right? Earlier it is in web server mode, but it is in AP mode. Now it is in the STM mode, right? So where through which actually you have to connect, to the existing router, right? So all these things, all informations you have to get. So you can see that how the simple Wi-Fi actually it's going to happen. Okay. I mean the simple file transfer is going to happen. Even in the Bluetooth also in the same way actually you can do the testing. Hmm. Mm. So how the communication, right? The Wi-Fi communication can be exchanged between the client, right? Or along with the router or along with the other things, other client informations. You can go through it. So you can see it here. It is going to be connected, right? This is the host IP address. So since it is in STM mode, it will get the IP address from the router. Okay. So sometimes it's the client getting disconnected. So now you just go to that things. So go to that web page, and then so that means uh, it works as an web server both in the AP mode as well as STM. That is a simple thing. Okay. So it doesn't matter if you want to control some remote devices with your ESP32. The ESP32 module can be configured as a web server, but it can use as an AP mode or it can use as a STM, right? In the both way, actually, you can configure it as a web server through which you want to connect some, control some remote devices. That's the messages. Now, thing is actually on the serial Bluetooth, right? So this example talks about your how actually the ESP32 Bluetooth module is going to connect with the other Bluetooth modules. Okay, so you can see it here. So this is a very important file. Try to obviously, and you select that particular example applications. So you will actually see that these header files will be going to be inserted, and all these these the macro definitions will going to be inserted in it, right? So actually there are two things actually. If you want to transmit some data or some text over Bluetooth to the client device, that also will be demonstrated, as well as from the remote device if you want to send, that is going to be transferred to ESP32 also. So you can see this is a terminal from the other Bluetooth device. So you can see it here. This is a terminal. So these other Bluetooth device is going to be connected with ESP32. So the connected has been done. Now you are putting some message, right? So that means this terminal is actually running inside your tablets or in your PCs. Now you see that hello text is actually come to your ESP32. Okay. Now similarly, you are actually putting some text here. That means you are sending the text from ESP32, and then you will see you can't spell. So that text message has also gone to that other Bluetooth client. So it's a peer-to-peer communication, correct? So one device is sending some information to ESP32, and with respect to that, ESP32 is also sending some information to the other Bluetooth client. Okay. Now this is one of the example for timer. You can see that how actually you can take the data from the that standard GMP time you can actually connect, and then actually you convert it to your local time. So this is what is actually it's talking about. Okay, so you can use that. So pool.ntp.org, that we already knows. There is a network transfer protocol through which actually you will get the GMT clock informations. And this is what the offset is that has been set. This is an arbitrarily we have set, but there are some websites actually through which where actually you can see. This is mainly with respect to the US time because it's a sample sketch they have given. But actually for Indian standard time, you can actually derive because you know what is the difference with respect to the GMT and you can put it. But we don't have any daylight saving options. So instead of daylight saving options, you can put it as a null, right? That will be as a null value. But GMT offset in terms of second, you can put it. You just calculate it and put it. So then actually you'll compute. So this is a the rest of the things is same. You just put your SSID, put your baud rate and all these things by default, and hopefully it will start. Just let me see uh, how actually it is, what it's generating actually. So with some loop actually it is go on printing. Okay. Yeah, you can see this. Yeah, this is what actually the time is. You see, Friday. This is actually the conversion is. So first it is going to be connected with the Wi-Fi, and then basically because it takes the data from the internet, right? So you cannot access it as a AP mode, right? So you have to access it in STM mode, and through which actually you get the internet connection, through which actually you access your pool.ntb.org, and then take the data and convert it and display it in the serial monitor. Okay. Now you see there is a sensor effect, one of the hall sensor which is already there inbuilt in it, so you can use it externally. Mm. So you can see that there is an option called hall read, right? So how actually you can read the hall sensors at 9600 baud rate. Okay. uh, so that's a default actually. You can just build a sketch and you can get it, and then you print the value. Now I just a little bit move it here. You can see it. Sorry. You can see the initially when there is no magnetic effect, you see the value of the hall sensor will be very high. Okay. You see the values are very high because there is no magnetic field. Now I bring a one magnetic item here, right? And now you see there is a substantial change has happened. So it has been reduced. Okay. So it detects the hall sensors is actually detects the magnetic field and read out the value. Okay. Similarly, there is also a timer. I just want to skip it here. So analog timers, all these things are there, or LED flashing control. You can see that I can control the intensity of the LEDs. Okay. So this is mainly timer applications. So you can use the timer here. Okay. Now repeat timers, I can just skip. So it's just generating the timing informations. Okay. Now one thing is that there is a touch. So there is a code for touch sensor actually. So this you just think just remember that that GPIO.4 normally is going to be used for touch sensors. So it will be available in the sketch. So no need to remember actually. So but just bring your notation that GPIO4 is going to be used for touch. Now if you see what is the output here? Yes, see this is the touch key, right? And now if I press it, so ESP touch test, now it's actually giving you the value. So touch sensor is actually sense and it gives you the value. The moment I remove my finger, it gives you the high value. Okay. So this way it is works. Now go to the camera part. And let's say if I can show you something on that. Yes, this is a camera module. Mm. So these are all the different camera modules actually is supported by ESP32 cam. Okay. So similarly, if I put the SSID password, then you have to baud rate and all these things you have to put. Okay, then you have to select the board. That's what is talking about. This Athinker ESP32 cam. This module is actually going to be selected. Okay. So first you go to the tools menu, then board manager, then find out the boards, and then you go to the file menu, go to the examples and figure it out. What are the examples available with respect to the board? This is the simple two steps you have to follow. Then probably you'll get the sketch. That's why this Arduino interface is very much easy, right? Now, so if I run this code, let me move that to that level. So Yeah, this is what you see. This is what the FTDI interface is. Just have a look on that, how FTDI is actually looking. Because as I said, though you cannot connect the micro USB directly to the ESP32 CAM board. It doesn't support. So you have to have an FTDI interface through which you have to connect it. Okay. And this is the camera, and this is the jumper. You see it here. This is the jumper actually. And this is what the brought out pins now. So TXRX signals, ground, VCC, and all these things, the standard one. Okay. Now, if I pass on here, yes, I have resetted it. Then after resetting it, yes, the camera is ready. It is going to connect the server. I mean, got the IP address, and this is what your application is, through which actually you will get the images. Okay, so you see it here, how the camera is working. So resolution is very low, right? You can have the VGA resolution, as I say, 640 480, but you can go to the SVGA also. CIF QCIF is extremely supported here. So for detection system, face recognition system, VGA is enough. You can go by that. Here also you can see that face recognition. If you enable this, it actually detect the face recognition also. Now the second thing is that, as I said about, there is some problem. You can use some sort of Belkin USB devices, which is an externally powered devices. If you face some problem, some brownouts is happening in the ESP32, so better you go by this Belkin type of powered USB port. Okay, similar to Ethernet port also. There are USB ports. So 4 port is there. 8 ports are also available. So you can use that. Then you can use it through a battery also. So it's a 9 volt, as you know, that 9 volt Russell batteries. So it is basically it is basically a additional DC power supplies. Okay, so which actually you can use. So this is what the Wi-Fi is. I mean, I'll just skip it here. So it detects the signals, and then yeah. So this is what the RSSI level is detected by the built-in camera, and this is what the external camera is. Okay, so let me stop it here. Move it to here. So now, how much time I have? Hello.
Yes, sir.
So how much time?
Sir, this is up to you only.
Oh, okay. Let's go to the next part, which is RTOS.
Yeah, after that, if you want to continue with the question and answer round, then you take it that also. Then we will over then.
Okay, fine.
Okay, sir.
So till 5 o'clock we have time, right? Now it is
Yes, sir.
4:30.
Yes, sir. Yes, sir.
Okay. Okay. Now, let's say, can I go to that on the current slide? Yes. Now we move up to the RTOS sections, right? So, so far what you have seen, most of the code, it is actually written in super loop architecture. So that means there is a bigger loop, there is a main loop, and we have different functions inside it. And all these functions is actually invokes from the main loop, and based on the structure of your programming, the functions will be called and it will return you the values. That is the traditional way we used to program. Correct. But these have inherent problems, right? So to overcome those problems, actually we have to create the real-time system concept. So real-time systems are those in which the correctness of the system. Then first you have to understand what is real-time system before jumping into articles. So what it talks about is that in which the correctness of the system depends not only on its functional correctness but also on the time at which the results are produced. So we ideally we used to ignore the time. If I get the correct answers or if we get the correct response, irrespective of the time, what our standard assumption is that okay, the code is running and the system is behaving well. But that is not real-time systems. Real-time system is even if you get correct answers, but actually it is not satisfy the time, actually it is not satisfy the time, then it is of no use. And that's why we classify it in terms of two categories. One is called hard real time and one is called soft real time. Okay. So real-time applications cover a wide range, but most real-time systems are embedded. Embedded systems typically do not interface with outside world through familiar. That we already know. Real-time software applications are typically more difficult to design, and real-time and embedded systems operate in constrained environment in which memory and processing power are extremely limited. So these are all the major criteria. And what I'm talking about is that soft, firm, and hard real-time systems. Let's say when we are watching any movie or any video, right? Uh, Either in your mobile phone. Nowadays, it's not happening. But in earlier, if you see some sort of VCP or video cassette recorder or video cassette player, you see that there are some lip sync is happening. Okay, so there is a time lag. Correct. When somebody is saying something, it is not matching with the video frames. So that means your audio frame and video frame is not synchronized. There is a time lag happens between the audio frame and the video frame. We used to call lip sync. So you have to synchronize your lip along with the videos. But this is not a very critical thing, right? Because over time, if there are some delays happening in the network, and if after 100 millisecond or 1 second or even after 10 second, if the lip is going to be synced with the video, you might have missed some words, you might have missed some dialogue, right? Some conversations. That's all it will happen, but it doesn't create any big impact to you. That is called soft real-time systems. Okay, so even if you get the correct answers or correct response, even after expiry of the expected time, it does not affect the performance of the entire device. Then it is called soft real systems. But that is absolutely not true for the hard real-time systems. Hard real-time systems means you need the data or you need the response at the very moment of time you have specified. If the data arrives at the later point of time, it is of no use. It will maybe a catastrophic failure for the system to work. Let's say an emergency brake, right? An autonomous car has to apply a brake immediately. So it's a very well established example. It should be a hard real-time system. There is no question of soft real-time. And the farm is in between, soft and hard, right? Neither it will be a truly hard, neither it will be a truly software system. So you have to trade off between these. Now, some examples are there. Digital fly-by control systems of an aircraft. No latency is accepted under any circumstances. So cannot accept any latency here. Otherwise, the aircraft is not controllable. Useless results if late. If the control system does not respond timely, the result is a hole in the ground, right? Catastrophic failure, which needs no explanation. Cost of missing deadlines is infinitely high. Correct? So all these things is meant for hard real-time system. But for soft real system, just like a vending machine, as it will take longer to treat a customer and the performance of the vending machine is degrading. But what happens, right? You are serving 10 customers, but the machine is not performing well, so it is serving 15 customers. Sorry, 5 customers. Okay, so or 8 customers. So there is a reduction, but that doesn't affect you. You'll get the Coke or can through the machine. So that is the fundamental differences. Okay. Now, as I said, the real-time system without kernel. So far, whatever you have said, whether it is an MSP430 programming, it is a ESP32 programming, whether it is a typical Arduino programming, whether It is a standard ARM7, ARM9 processor programming. They are not using kernel. They are simply super loop architecture. Different functions is meant for different tasks, and they are executing in an infinite loop in a sequential order. That's what the point is. Okay. And to some extent, you have ISS, which is interrupt service routines, which is going to what? Which will take as a high priority event. When there is an interrupt, your task is going to be suspended, or your function which is going to be executed is going to be suspended for a period. The ISR lets the ISR gets control over the CPU. It executes it, the ISR service routine, and then it releases the CPU for the to resume the task which is left over. And it's go on happening. Even ISR has a nested ISRs also. If you go by MSP 430, you will see that you can even define the priority of ISRs. That means some ISRs will be of higher priority, some ISRs will be of lower priority. Okay, so that means there is a nested ISRs can be used inside MSP 430 or even for ESP32 also. But still, I can say that there is no RTOS. There is no concept of RTOS. Okay, it's just a combination of background task and different foreground task. Right, background task is nothing but your this serial task which is happening in an infinite loop, and foreground task is nothing but your ISS. It may be a keyboard interrupt, it may be an ADC interrupt, it may be a timer interrupt, it may be a DAC interrupt, it may be a power brown on interrupt, whatever. Correct? Now, these are simple examples, right? You see here, I have to check the keyboard. A very simple example I have given for the conceptual point of view. If it is in a sequential manner, if it is in a infinite loop manner, or we used to call super loop architecture, right? So you have to do it forever. And you cannot do once, because check keyboard is very important for you, because you cannot assign any priority for all the functions, whether it is a keyboard checking, whether it is a temperature measurement, whether it is a control over power, whether it is a display, right? You don't have any priority over them. All functions are actually running on same priority. Then if you want to do some job most frequently, and if you want to do some job least frequently, how to differentiate? There is no way to differentiate. Only you have to insert or you have to invoke that particular functions in a fast manner, right? Or in a repeated manner. That's why on the right hand side is. See, to me, keyboard checking is an important task. It should be a higher priority task, because let's say the alarm has been pressed, the system has to immediately respond. Correct? Then I have to check whether somebody has pressed the alarm key or not with a frequent interval. And that's why I put all these codes one after another. Check keyboard, check keypad, like this. So repetition of functions calling is happening. That's a major bottleneck. And to overcome this, actually, we have to introduce real-time systems, right? Or I mean, real-time operating systems, RTOS. Okay. So key factor in an RTOS are therefore a minimal interrupt latency and minimum thread switching latency. That means in an RTOS, if you install, right, whether it is a free RTOS, whether it is a new COS, whether it is a QNX, it is a TEDx, all different variants of RTOS are available in the market. And you have to choose which RTOS will be most suitable for your board. Maybe RT Linux also, correct? But that give you the liberty of defining the task individually. That give you the liberty how actually assign the priority of the task, which is a higher priority task, which is a lower priority task, right? All these things will be given. See, this is what the architecture is. There is an hardware at the bottom level. There is an RTOS on top of it, and there is an application software. So all the softwares, whatever you have seen earlier in the sketch files, I can run all of them along with the RTOS. And I need not to structure in a super loop manner what currently they are. I can do it in a very different way. And what are the tasks is exactly executed by RTOS? It is all these things. See, timers, IO supervisors, memory allocations, task management. There is a key. The heart of the RTOS is task management and inter-task communication and synchronization. Right? So these 3-4 functions are the integral features of the RTOS. So whenever you use any RTOS, you check all these features are there or not. How do you check? By writing different type of codes and then finalize, yes, this is what you want. Correct. All RTOS may not have all different functionalities because it is not a standard operating system or native operating system which is running inside your desktop. No, do not just try to understand that. It is no longer a general purpose operating system. It is a stripped down version of the general purpose operating system to a larger extent so that it can run on an embedded systems. You do not need a you know Pentium processor for this, or maybe i6, i5, i6, i9 processors like this, right? It run on a microcontroller, it run on an ARM processor. It's a stripped down version. So a lot of things is actually going to be reduced. And your general purpose operating system doesn't have preempting capability because it's having on a round robin scheduling basis, right? But your RTOS should have preemption capability. That means it can preempt whenever there is a higher priority task. That higher priority task is going to be executed by preempting the lower priority task. That means you can preempt the lower priority task, execute the higher priority task, and then go back to the lower priority task. Correct? That is the fundamental things is going to be handled by the RTOS, and the program which is going to handle it, it is called scheduler. Right? So it's very important to understand how the scheduler works. Okay, so these are all the basic definitions, right? So hopefully, if you are familiar with RTOS, you should know that the task should have priorities. Critical and time-bounded functionality should be processed by tasks having higher priorities. It should have preemptive. That is, when a task of higher priority is ready to run, it should preempt a lower priority task. It should have a mechanism to avoid priority inversion, supporting priority inheritance. So priority inversion is also a very important thing, and how you can actually support priority inheritance. That means sometimes it is going to happen that, say, a lower priority task actually block a resource. Correct? Then a higher priority task has came. The moment the higher priority task has came, since the resource is blocked by the lower priority task, it is not going to gain it. Correct? Because it's a common resource, and common resource is normally used to handle by the semaphores. If you have operating system concept, you will understand it, either by the binary semaphore or by the mutex. The point is, what will happen for the higher priority task? Will it be blocked till the lower priority task is going to release the resource? There is a question. Then the concept of priority inheritance will come into the picture. That means temporarily I have to raise the priority of the lower task more than the priority of the higher task, and allow the lower priority task to complete the job and release the resource immediately so that the higher priority task can use it. That is what called priority inheritance. Okay, so you are actually inherit the priority and do the priority inversion. Priority inheritance is a mechanism for what? To implement priority inversion. So you have a lower priority task, but you are inverting its priority to a higher priority task so that you can release the resource which is blocked by itself. So that's a major thing is here. Then it should have predictable interrupt latencies, right? Because in the task you have ISS, correct? Your high priority task can be interrupted by the ISS. That is also possible. Or vice versa. Your ISS can get interrupted by the higher priority task also, right? So it's your ISR should be very much deterministic, right? Otherwise, you can miss the deadline. So it should offer a constant time message passing scheme. How actually you can, you know, pass the messages between the tasks. That is also very important, right? Whether it is in the form of mailbox or whether it is in the form of message queues that you have done. How to synchronize the messaging also. All these things are very important, right? And finally, allocations. How actually you can allocate the memory, how you can free the memory, right? So you see that the large number of tasks can disadvantage. What are the advantages? Better control of priorities, better sharing of hardware, better modularity. But what are the disadvantages? More stack space and more memory is required, more time lost to context switching. Normally it's happening, right? More the task you have better control. But on the other side, you have more memory switching, right? More stack space is going to be utilized. All these things are potential problem inherent to how many tasks is actually going to be generated by your code. Okay. Now there are some. Sorry, I have skipped it. Sorry. Uh, just a minute. Just a minute, maybe. Yeah. So there are some cardinal rules actually I'm going to talk about. So these are the when actually you're going to design this. So the cardinal rules are: avoid creating and destroying tasks while the system is running. Consider turning time slicing off, right? So it will give a fairness to zero. Takes tasks are not equally urgent. So you can the time slicing operation actually you can off it, right? Otherwise every task will get of equal importance. Consider restricting use of RTOS, right, to its minimal necessary subset by reducing number of different IPC mechanism, by restricting number of data formats, by putting a shell around RTOS. All these things are normal, the general rules. Reentrant and the non-reentrant functions. Okay. A reentrant function is a function that can be called. So when you play with RTOS, you should know how to write a reentrant function. You should know how to write a non-reentrant function. And most of the time, when actually we are writing the code in a simple loop architecture, they are non-reentrant functions. Okay. So never use non-reentrant functions, right, in a critical section. So that means critical section means what? The code actually going to be shared by all the tasks. They access the mutex, they block other tasks to access the code, and they are going to execute that critical section code and get out of it. But that should be reentrant code always. That should not be non-reentrant code. So a reentrant function is a function that can be called by more than one task, and the results are guaranteed to be corrected regardless of any task switching that may occur while executing. Okay, that's a very, very important thing you have to understand. Let's say you have written an ISR code in a non-reentrant function, and if while executing the ISR code, it is being interrupted by a higher priority task, then your data may get haywire. So that's why your ISR should be reentrant function always. Even if there is a task switching happens because your ISR has been interrupted by the higher priority task, there is no data corruption is going to be happened. Okay. So application code using a preemptive kernel should not use non-reentrant functions. So all functions, whatever you are right, that should be reentrant. Correct? You have to utilize it. So how you can build reentrant functions? No. If you just declare the variable by static, it doesn't generate you the reentrant function. Correct? Let's say static integer uh, x, it will not going to work. You have to introduce the concept of mutex. You have to introduce the concept of binary semaphore. Then only it is possible for you to generate reentrant functions, which is not there in the serial loop or in the Boogle loop architecture. Okay. So block task switching, I'm not going to details on that. So this is the different task transitions we already know. So when a task is become ready, it can go to the running state. From running state, it can go to the block state. From block state, it can go to the suspended state. Then it can again come back to ready and run. All these things are go on happening. It is actually maintained by the scheduler. Correct. So there is no need to write a scheduler for you. Moment you deploy the RTOS, the scheduler will be there, right? It is already, it's a very good experience if you can write your own scheduler, but it's not a cup of tea to write a scheduler. Okay. So different type of task switching I'm talking about, right? This multitasking versus concurrency. So you can see about here, this is also, you can see that how the lower priority task is going interrupted by the not interrupted, preempted by mid priority task, and then higher priority task, then again come to mid priority task, right? These are all the sequence diagram you can see. So through this actually you can understand. So what is the design rule is, first you have to understand what are the task is required. Then you have to understand that how frequency or at what frequency the task is going to be executed, right? Some task will be executed at a faster rate, some task is going to be executed at a slower rate. So based on that, actually you have to assign the priority of them. Let's say you have priority 0, that means lower priority. Then 1, 2, 3, 4. So when you actually study the RTOS, you try to figure it out how many different type of priorities can be assigned to the task. Okay. And what are the different levels based on which you can assign to the task you are going to create. So there is a way that you can create a task. The way actually probably in the Unix system, if you do some programming, you know how to create a process, right? And how to kill the process also, correct? And how to start a thread and how to stop the thread. All these things probably you know. Pre-thread is a very good example in Unix. So for thread programming, okay, the same way actually you can create, but you know the APIs or the way you define the functions will be different based on the RTOS you're going to use. Fine. So static and dynamic priorities, it is not something like that your priority will be always static. You can change it dynamically. That's why I say, so if there is no, what I can say is that if there is no dynamic priority, then it will be very difficult, right, to incorporate priority inheritance, right? Because you cannot uh, do the inversion of the priority. If we cannot invert the priority, then the whole story boils down there, right? There is nothing to do, and that's what. This is the thing where actually the VxWorks fails in the very beginning, right? They don't have the feature. VxWorks is the most popular real-time operating systems, but it was fails right when it was launched because it doesn't have priority inversion by using priority inheritance. Okay, always remember that it's very very important. And how to switch between static and dynamic priorities. Okay, assigning task priorities, I can say that the range of priorities is configurable, so 0 to desired amount. Now when you choose your RTOS, you figure it out what is the maximum priority you can give. Okay, so if you use free RTOS, you will say that you will get free RTOS config.h, where actually you can have you can define that how many priorities is going to be supported by the free RTOS. It's a free version. You can directly use it. You go to the free RTOS website, download it, and make it ready. Even it give you the list also that what are the different types of boards is going to be supported by free RTOS. Okay, most of the 8051 derivatives is going to be supported by free RTOS, no doubt about it. Okay. Now, how to implement a task? You see, there is a task creation, task deletion, right? X task, B task delete, right? And obviously, there should be the body of the function, right? So you have to create a task, then you have to define the body of the task, right? What the task is going to do, or the job it's going to be done, and definitely it will be a for loop, right? Infinite for loop is going to happen, right? This is the standard practice to create the task. Now there is coroutines also. In free RTOS, probably you'll get coroutines. I don't know whether it is there in TEDx or not. The coroutines is, you know, it is similar to task, but you know, when I create a task, let's say if I go to that earlier figure, right, the very thinking, just visualize it, right? There are n different tasks are there, and n different stacks are going to be used, and each and every task have their own task control blocks, correct? And your scheduler is going to switch from one task to another. It may not be switching in a you know, clock driven mode, that means in a round robin fashion, that periodically it is go on switching the task, but it is based on the preemption. But when it's preempt, basically it switches the task control block. The moment it switches the task control block, your stack is also going to be switched. That is what you are going to preserve your contents, correct? That is the usual procedure for any switching. Okay, but in case of coroutines, the key difference is that you can share the stack, you can share the task control block. That is the beauty of coroutines. Okay, if I have 5 different tasks, I have to maintain 5 different stacks as well as 5 different task control blocks, because task control blocks is nothing but what? Array of pointers, correct? But if I actually create coroutines, but you have to be very, very careful how actually you're going to coroutines, because it can give you a haywire, right? In the one side, it will give you the best performance. In the other side, it will give you the worst performance if you cannot code it properly in a structured way, right? Because it is going to share the task. It is going to share the stack. It is going to share the task control block. That's very difficult. So this is one of the way how actually you can start and you can end the coroutines, how actually you can create. This is one of the body also. So this is how actually you can pass the arguments, right? Coroutine handler, and then there are some type also. Type of coroutines are actually you can define. Okay. So if you go to that, I'll just give you the skeletons, because if I write the code, it will take you know, 2 hours to explain, right? What is the functionality of the code? It cannot be a tutorial. So it's a very in-depth, in-depth understanding is required. So, but the structure is more or less same. The way you are going to create the task, in the same way you are going to create the coroutines also. But this handler is very specific. This is going to handle, this is going to manage how it is going to share the task control block as well as the stacks between the coroutines, as well as between the coroutine and the task. You can have a mix and match also. You can have series of coroutines. You can have a mix of coroutines as well as task as well. Okay. Say now there is a whole coroutine is blocked if the stack is not protected. Variable on the stack can change. All these things is a problem. Now, what type of different schedulers are there? Clock-driven schedulers, priority-driven schedulers, right? These are all mostly used. Clock-driven schedulers is normally going used in the desktop applications. Priority-driven scheduler is mostly used on the RTOS. So this is what the priority inversion is, and this is how actually the shared resource is going to work. You can see it here. This is the shared resource, right, where all the task is going to share. So this is the TCP for task one. This is the stack for task one. Similarly, this is the TCP for task two. This is the TCP and stack for task three. And all these things is actually sharing this, through the message passing or maybe some uh, message queue or maybe some mailbox through which actually all these tasks is sharing the data. But definitely you should have a proper synchronization, right? Proper synchronization of the shared resources. These code will be a re-entrant code. It cannot be a non-re-entrant code. Always please remember that whenever there is a code base which is actually written for message passing, message sharing, right? You treat it as a common resource for n number of tasks or for the n number of routines, right? This should be a re-entrant code. Correct. Now memory allocations is all there. Now you can see this is a fundamental code how actually you can create a task. So this is actually I have taken from the free RTOS because I've used free RTOS. So it is init RTOS, how you can initialize the RTOS. That means it is going to initialize the scheduler. Then actually you can start the task. This task is already defined. In the body of the function, you have to define these tasks. So there are two different tasks. One is called respond to the button, calculate the tank levels, right? This is of higher priority, this is of low priority. Then actually you have to start the RTOS. This is the initial part of the code you have to do. Right now, these are all the task definitions, right? So while true, that block until user pushes a button, quick respond to the user, right? So it is a blocking code basically. Until and unless you are going to push the button, then only it will going to respond to you, right? Similarly, it is a high priority task always because you have pressed the button means you need immediate response, correct? So even these calculation of the tank levels is actually executing, it is going to be preempted by this respond to button task, okay, because it is of high priority. So it's very intuitive. Okay, so now this is how actually you are sharing the data between the two tasks also, right? Now you can see it here. This is the code. This is the common code, right? Or this is the code which is actually running inside the critical sections. Correct. Now, before running this code, how actually I make it re-entrant? Because I have used take semaphore and I have used release semaphore. So moment I use these two attributes or two functions of the RTOS, actually I make this part of the code becomes re-entrant. Okay, because the tank data dot time updated and the tank data dot tank level. So this is what, this is nothing but the structure, right? And these are all the structure variables. Okay, so most likely it is going to be corrupted if I cannot synchronize it in this way. Correct. So if you simply write this, your current as well as the result will be completely corrupted when there is a task switch happens. So you have to have a uh, very very see the easy thing is that it is embedded. The critical section is always embedded in the task itself. Okay, but it may not be correct. It may be a separate function also. So then you have to think that how actually you can invoke that function. Correct. Now these are all the different available RTOS, right? Real-time kernel, Mucos, Logic. I talked about ThreadX. ThreadX is actually developed by Express Logic, but nowadays it is available on the Eclipse, right? Pre-RTOS, as we say, RT Linux. This is another thing. Now go to the Mucos. Mucos is the very popular thing. So you can see it is a preemptive kernel, it is a deterministic kernel, it is a royalty-free kernel. You need not to pay anything. Then extensive documentations are available. You can see on the right hand side how many functions is actually supported by mucos 2. It is not, I have written mucos 2 here, but actually mucos 3 is also coming to the picture. Mucos 3, instead of 2 it becomes 3. Okay, so more advanced versions. So you can see it here. It has supported TCP/IP. It has supported USB host. You know, there is a difference, right? There are three modes of USB. One is USB host, one is USB device, and the third one is OTG, right? One time go. So it can also support. So all these actually built-in modules or built-in loadable modules inside the mucos. Okay, in terms of kernel, we used to call LK, loadable kernel modules, right? Sometimes module are statically built. Sometimes modules are dynamically built. So when I say dynamically built means it is loadable. You have to load the kernel because you have to load that particular functions before using it. Okay. So this is a CAN interface. This is a Modbus interface, right? So this is a flash functionalities. This is a monitoring functionalities, probing, right? You can monitor the real timeness, right? You can actually use the timer functions and see how fast it is executing. Okay, so this is an interface for file systems, correct? This is an interface. I mean, interface means functionality supported. The file system functions is going to be supported by this. Okay, these GUI functions will be supported by these libraries. So these are all different type of libraries tightly integrated inside Bluecost. Okay, which is a preempted kernel. Now, how actually you can organize your applications if you use mucos, right? So you can see this is a target board. It may be ARM board, it may be your 8051 board, it may be your MSP 430 board. This is the board support packages. You have to directly avail this, right, from the mucos. So if you actually select that this is the board you are going to use, you will get such type of board support packages, right? If it is not there, probably you have to write these board support packages, right? The way you write the timer code, ADC code, DAC code for MSP 430, the same way actually you can write. But there should be some, guidelines to write it. And there are some ports already available, right, for that particular port. So these are all the standard ports which is available for them from the mucos. So port for memory, port from message box, port for mutex, right, port for semaphore, port for timer, port for task. All these things are already available. So you can directly use it, and then finally you can actually develop your own applications. So try to remember this is what the structure is. In one side you can get the port means what? Port means compatible code for the board you are going to use, right? Because all the boards are different with respect to the processor and their peripheral support. So any RTOS provider has to give you the ports, otherwise they cannot use it, correct? So because there are a lot of varieties, it's not a, you are mostly dealing with or AMD processors, or nowadays people are using GPU servers, right? So hardly 3-4 vendors are there. But in case of embedded systems, you have a plenty of manufacturer, right? You can get the board from ST Microelectronics, you can get from Freescale, you can get from TI, you can get from Blackfin, right? Analog devices, right? Who are actually best in the world for DSP processors, right? Peak microchip, so innumerable, right? Companies are there. So every RTOS provider will give you the port for a particular port. So you have to be very specific when choosing the RTOS, that RTOS is going to support your board or not. Otherwise, you cannot work with that because you cannot write this port. It's very difficult. It will take a hell lot of time to write these ports. So you have to be very choosy that when you are actually going to select the RTOS. But BSPs you can develop because you know the microcontroller code, you know the ARM code, so you can write your own BSPs compatible with respect to the RTOS you are going to be used. So your job is done. Your BSP is ready, your port is ready. Now you have to develop your own applications. Correct. So if you can put this effort in your SIH project, I'll guarantee you that it will be a game changer because hardly people use such type of approach for developing the approach. People just take the Arduino board and use it. But that is not the thing. Okay. Now task is also the same thing. How actually you can create the task, right? The same way I have on in the free RTOS also. Here also the same thing, but the parameters are different, right? You can see it here. If it's possible, I can share you the slide also, because a lot of information has been captured. What the parameters are mean, what is the meaning of these parameters, right? These are all different type of pointers. This is the for the priority, this is for the ID of the task. Okay, this is how you are going to declare the stack size. Okay, similarly, how actually you can initialize the ways, how actually you can create the task, then how you can start the ways. So this is are fundamentally same, right? You initialize the start RTOS, then you create the create the task, and then this is the body of the task, and then you start the operating system, right? This is way. So because there is no bootloader, right? In case of general operating system, there is a BIOS and there is a bootloader, then there is an OS which is going to bring up, right? Bring up the root file system, correct? And give you the GUI to start the work. But here, this entire flow is missing. Actually, there is no bootloader until and unless you are not going to embedded Linux like stuff where actually you have a U-boot loader, then the kernel is going to be loaded. In case of microcontroller operating systems, I mean RTOS systems, you won't get bootloaders. So you have to initiate, you have to start your operating system. That's the point is. Correct. Hardly we understand when the way starts, because it is the bootloader who is going to take the entire responsibility. But here you will really, if you implement this, you will really understand that how waste is happening, how waste is actually taking care of all the tasks. So it's really fantastic. So this is the task definition. I can skip these things. These are the different task states. Okay. Initialization, execution flow. Now moving to the ThreadX, a little bit fast. Otherwise, I don't know how long it will take. So this is what the ThreadX is. It's a very important nowadays.
Sorry to interrupt you, sir. Uh,
Yes.
Due to some time constraint, please bind up the session now.
Okay. May I complete this? Just 1 or 2 slides.
Yeah, so it will take how much time?
Another 2 to 3 minutes. I will stop it here.
Okay, okay, okay.
I will
Okay, sir.
not go to the RT Linux part, right? Because due
Okay,
to the time
okay, sir.
constraints.
Okay, sir. Continue.
Okay. Okay. So just for the information, this is an Eclipse ThreadX is an embedded development suite, support for most popular 32-bit microcontrollers and embedded development tools. You can see just it's a vendor neutral. That's what I'm saying. So plenty of boards is going to be supported by this. You just browse this project eclipse.projects iot.threadx. It is mainly for IoT applications. So the ThreadX actually become open source, and it is actually plugged with the Eclipse environment just to create, mm, give you a ample space to play in the IoT space. That's why it has been, it is become open sourced. Earlier, it was not open source. When I started my career, ThreadX was a completely license-based software. Okay, so and these are all the different features it is supporting by. So this is the basic kernel ThreadX, advanced real-time operating systems, which is also a preempted version. I mean preemptive kernel. Always remember, these kernels are preemptive kernel. They are not clock driven kernel. They are preemptive kernel, right? They inside in it, it may be a event scheduler, and in it there may be a it is called rate monotonic scheduler. Inside it, it may be a laxity time, or maybe earliest deadline first scheduler, EDF, right? So all these things are already there inside the ThreadX. Then next duo, advanced integrated TCP/IP stack, right? Industrial grade TCP/IP network stack. Then FileX is nothing but high performance, fat compatible file systems. Then GYX provide you a complete embedded graphical user interface. USBX high performance USB host. You get the entire code base. If you browse it, you will get all this code base, and I'll give you the name, just the name, and what is the purpose of the code base. I'm just highlighting you. High performance USB host, device, on the go. All are supported at the same time. Okay, that is fully integrated with the ThreadX kernel. Then Flash labeling and Flash operations, right? Then GUI interface, designed interface, facilitating the creation and maintenance of all graphic interface. Then Trace, it's a fantastic, actually, the supporting function by which actually you can trace the task, you can trace the TCB, you can trace the stack pointers. and you can actually create the entire stack flow also, how it is going to happen for debugging, right? The way Valguard is used to work, right? In Linux, if you are very familiar, most of the time I used to use Valguard, right? So that I can create a graphical interface to figure it out how the task switching is happening. Okay, it actually give you a representation in the form of a graph, in the form of a leaf nodes also, right? So that you can actually trace down. So for the interest of time, I should stop here. I cannot complete RT Linux. uh, so if there is some time, probably I can get in touch with you, but this is a very important topic also, where the basic things I'll just want to show you. This is what the difference is, right? In the right hand side, you see this is a GPOS, general purpose operating system Linux kernel, where this is a Linux kernel, clock driven kernel, which actually has a round robin scheduler, but actually it interacts directly with the hardware. But if I want to use RT Linux, actually you have to apply a patch, which is called RT Linux plugin. I have some video also how actually you can apply those patch. Let's say if I take download some kernels, let's say 6.0, 21 or 28. This is the latest kernel, right? Now running. So go to the kernel.org, download that kernel, right? Then go to the kernel.org/rtlinux, download the rtlinux patch. Then apply the patch on the kernel, and then actually you have to do kernel compilation, right? The way you are doing all these things in the embedded environment, right? You have an IDE through which actually you can compile your entire RTOS along with your functions. But here you cannot do that. The fundamental difference is that first you have to build the RTOS, and then actually you have to deploy the RTOS, right? So how you are building the real-time Linux is you download the Linux kernel, apply the patch, and then put it into the device. Then your system will be ready for RT Linux. Then on top of it, you have to write your user processes, okay, or application codes, which actually interact with the kernel through system calls, as we always know, right? So for Linux programming, we are using different type of system calls, right? Whether it is a pthread, whether it is a kill function, correct? Always, right? So we are using different type of system calls so that we can interact with the you can change the PID values of the task also, right? Dynamically you can change the PID values, I mean the process ID values, right? All these things you can use. But here is the main difference. It's a RT Linux patch which gives you the RT scheduler, which normally is not available. And this is what the flow is, how you can configure, right? This is the organize the source, how you can patch it. This is the instruction. This is the code base for the main Linux code. This is the main kernel code, and this is the code base for RT Linux, right? You tar it, and then actually you can link it also. These are all soft links. Then actually you can apply the patch. Then this is what the kernel compilation is: make menu config, make diff, make module install, make install. So moment you say make install, it is going to be installed, right? So this is what actually you can configure your RT Linux. Okay, thank you for interest time. I have wrap up quickly. So if you have any questions, free to ask me, or you can mail me down also in the later point of time. I'll be very happy to answer you if I can. Thank you. I'll stop sharing.
So, thank you everyone for your active participation, and a special thank to our trainer Sri Ranjan Das Gupta ji for sharing valuable knowledge and guidance and made this session wonderful. We wish all SIH 2025 participants the very best for your journey and innovations. We are closing the session now. Have a great day ahead. Thank you once again, sir.
Thank you. Thank you, all of you. Bye.